And in this video, we're going to talk about the question which names k alternating strings. So let's try to understand the problem. So the problem says that you are given a string s and which has the size n. You also have been given an integer k and k ranges between 1 to n. You have to print the minimum number of flips required to make at least one string of size k alternating, right? What does this mean? First of all, let's understand what is alternating. So it says a binary string is alternating if no two consecutive characters are the same, right? For example, 10101 is alternating because no two consecutive characters are same. No two consecutive characters are same. Here you can see there is no two consecutive characters that are same. So that is alternating strings. The second is 0101. So here also have no two consecutive characters are same. So this is also alternating string. Let's take one more example. 11010. Is it an alternating string? So the answer is no, because this 1 1 two consecutive characters are same. Right. So what we have to do with this consecutive characters? So we have to make at least one substring. We have to make at least one substring of size k alternative, right? Let's take examples and then try to see. So here, let's take this example, which is 53101001. So here the size of the string is 5, which you can see, and you have to make k size string alternating, which is 3 size string alternating, right? And what you can do, you can perform one operation called flipping, right? You can convert 0 to 1 or 1 to 0. So how will be going to do this? So let's try to have this. So let's try to pick the 3 size string. So here it will be 101. Do I require any flip? So it is already alternating, right? So you do not require any flip. So it's all good. So if I'll go again in 101, it's again for this we require 0 flips. For this, it's again alternating by itself. So we do not require any flip. And then we have 101. Again, no flipping is required. So we can say that, hey, for this, to make the k size, to make 3 size string alternating, you require 0 flips. Flips are required are 0. Okay. Let's take one more example, which is this 6 6, and you have the uh, string as this. So you have to make 6 size string alternating, right? 6 size substring alternating, right? So here you can see that it is absolutely not alternating. So what we can do? So to make it alternating, just see this observation. To make it alternating, either I can convert this string into this 010101, right? If I wanted to convert this string to this string, how many changes I have to make? See, this is 1 here, this is 0. So we have to convert this to 0. So 1, right? 1 1 is same. So do not no flip is required. No flip is required. It is again different. So one flip will be required here and one flip will be required here because they are different. For same, we do not require any flip. It's already same. So here you can see, if I wanted to convert this string to this string, I require 3 flips. Can we convert it to some other string? Can we convert it to some other string? Yes, we can convert it to other string, which is 101010. See, to any string, to any given string, either you can convert it to 1010 and so on, or 010101. Do we agree? So there are only two possibilities. So I just tried to calculate it on the first, right? What is can we convert it into this? Now I'm taking care. If I convert this into 101010, how many flips are required, right? So in this scenario, the number of flips required is 0, 1, 1, 0, 0 1, right? I just said ki if they are different I have to flip them. So three flips are required. So you remember before also three was required, and after also three is required. And think about it, this three and this three sums up to six, which is the length of the string, right? Why it sums up to six? Because think about it, the strings, both of these strings are alternating, right? So if you wanted to make the string, right, and let's say x flips are required, then for this n minus x will be required. Why? Because they are complementary, right? Okay, hope this makes sense. Hope I think flipping logic is clear, right? So the number, how many numbers are different, how many binary string are different from the alternating string, right? We can fetch the number of flips from that, right? Let's take one more example. Let's take one more example. Let's say the example is 1 1 1 0 1. So here I wanted to find out, hey, how many flips are required to make this as alternating, right? So let's try it out. So either I can convert this to 1 0 1 0 1 or 0 1 0 1 0, right? So let's try to convert it to 0 1 0 1 0 and see how many flips are required. So let's convert it to this. So for this, you can see this flip will be required. This flip will not be required. This flip be required. This is also required. This is also required. So four flips are required if I wanted to make this string into this, to this, right? What if I wanted to make it a different one? How many flips will be required? As we have seen, if x is required to make this, n minus x will be required for this, right? So n is 5. So 5 minus 4 will be required if I'll be converting it to other part, right? So 1 will be required, right? And see, that is true, right? Let's write it down again. So you will see 1 1 1 0 1. If I convert this to 1 0 1 0 1, so there is only one different, right? This one is different, other thing is same. So if I'll flip this, so this will become alternating, right? And from also here also we got one, right? So are you getting the flipping logic clearly? First of all, right? I hope yes. Now there are many problems, right? So we are not dealing with exactly this part. So what we have given is a binary string, right? Let's say this is a binary string, and you have to make five size, five size, five size alternating string, right? How you can do it? So it's I think easy. What you have to do, you just have to take the five size window. Now in this window, I will check, hey, how many uh, things are different, right? From example, I can either, let's start with, I wanted to make all of them 1 0 1 0 1, right? This is one choice of alternating. So if I wanted to make this string to this, how many flips will be required? This is different, this is different, this is different, this is different. So four is required. If I wanted to make this to other part, then one will be required. Think about it. So the other alternating string will be this. And since four are different in this case, so only one will be different in other case, right? So again, you can take minimum out of it. So I can say, hey, one flip is required to make this alternative, right? Similarly, you will move and check for other window, which is this, right? And here you will see, hey, how many flips are required? So again, I can compare it with, let's say 1 0 1 0 1 0, right? Let's compare it with 1 0 1 0 1 0. So it is same, right? So zero flips are required. Again, I can move. This is again zero flip are required. Again, I'll go forward. Again, zero flip is required, right? I can take few more, right? And here as well, here one flip is required. If I go forward, some other answer will come, but you can see the minimum can be zero, right? Number of flip less than zero is not possible, right? So the minimum you can go is up to zero, right? Okay, hopefully that makes sense. And are we getting this part? How we can find? We can slide the windows, right? Okay, but let's try to analyze what is the complexity if we are sliding one by one. So if we are sliding one by one, so we have to iterate over the array. So we are over iterating over the array once, right? And each time, k times, we are checking if how many how many character we have to flip. So on for iterating and ok each time for checking if how many flips are required. So the overall complexity is on into k. And I think this will not work, right? So we have to think something more efficient, right? So one thing I can think of, can I reduce this time? How many flips are required? Can I reduce this time? How can I reduce this time? So this technique is called prefix sum. So we'll be using that technique and see how awesome this technique is. So let's say this is a string, right? Okay, let's see. And you wanted to make four size. Let's say k is four in this scenario, right? So what should we do? Again, you will be taking a window, right? Let's start from here to here, right? And now want to find what are the flips required. So what are the flips required? In this scenario, I think one flip will be sufficient, right? But how you will find this? Okay. So what I'll do, I'll take one string, right? Let's say 10, 10, 10, 10, right? And I'll try to find how many flips required to convert the whole string into this, right? See, here is it required to change? No. Is it required to change? Yes. Is it required to change? No. Is it required to change? No. No. Is it required to change? Yes. Is it required to change? Yes. Is it required to change? No. So overall, three changes are required, right? If I talk to make this as substring, this as substring, how many, if to make this substring alternative, how many changes are required? How many flips are required? See, you require only one change. To make this as alternating, how many flips are required? Just go through this. You require only one, right? Because there is only one. How many required, let's say, in this scenario? So in this scenario, 1100, you can say if I wanted to convert this to 0110. So 2 is required, right? Now you will say, hey, okay, you are taking only one scenario, right? We can also convert it to 010101 as well. So yeah, so let's take the counterpart. You remember the counterpart, how to calculate the counterpart? Key what number of flips required to go. For example, here we are going from for 1010. How many required to go for 0101? It is nothing but 4 minus 2, right? 4 is the length we are considering, minus 2. In this scenario, it will be 4 minus 1. In this scenario, it will also be 4 minus 1, right? And you can take minimum of it and you can resolve that out, right? So if you will see, the number of ones here is actually your answer for any substring, right? So what we can do? We can do the prefix sum, right? Let's see the power of prefix sum. So this will become, see, I'll just add, when I'm going through it, I'll just add the previous thing, right? So till now, what is the sum? It is 0. What is the sum till now? 1. What is the sum till now? So if we'll add this, only 1. What is the sum till now? It is 1. What is the sum till now? It is 1. What is the sum till now? It is 2. What is the sum till now? It is 3. And what is the sum till now? It is 3. Do we agree? I just accumulated everything. So basically, this 2 means the sum from starting to here. So it is the sum of prefix. Okay. What similarly, what this 3 means? So 3 means the sum from starting to this part, right? Now, like you can easily identify how many ones are there. For example, let me write this first part again. So this is the first part, right? And let's say this is the first part, and let's say you wanted to find, hey, what is the number of ones available? So this is 3, this is 1. If you subtract 3 minus 1, it is 2. And these are the number of 1 as a character available between these, and this is 2. Similarly, just take anything, right? So if you'll take this, you will say, hey, how many ones are there in between? So you will take this 1 minus the starting point. There is nothing in the starting. So 0. So it leads to 1. It means there is only one available. Do we agree? So after aggregating all, let's try to write the code. Let's move to the code.